Alright, it's time for the video that so many of you have been waiting for. I'm going to show you how to configure a custom Linux kernel. And this is one of the main reasons why people choose to use Gentoo, although you don't necessarily need to be running Gentoo in order to have a customized Linux kernel. You could do this on Arch or Slackware or pretty much any distro really, but because this is more of an advanced Linux user thing to do, people just tend to use a more advanced distro like Gentoo. Now, a new kernel configuration is something that you typically want to put a lot of thought and planning into before you just dive right in and do it, because the kernel is what actually allows for communication between the hardware via drivers that are either built into the kernel or added via kernel modules, and then they talk to the software. And it's also responsible for the efficient management of the system's resources, such as memory management, process and task management, and disk management. So your kernel configuration is going to be different depending on what hardware and software you're going to be using, as well as the goals that that hardware and software harmony are going to accomplish. So for me, my goals are that I want to have a high-performance kernel that is small in size and has a low memory footprint, doesn't really need to eat up a lot of RAM or a lot of CPU time. No unnecessary software or hardware support, so if I'm not going to be using a particular piece of hardware in my system, like I have a Intel CPU in here, so there's no reason to build anything AMD into my system, except for maybe GPU support, because I do plan on getting an AMD GPU, but that's something that I would do later. Right now I'm just going to build it to be NVIDIA and VirtualBox graphics. But yeah, if I'm not going to be using it, no reason to build it into my kernel. And minimalist security only, no bloat. And this is kind of important. So a lot of security in the whole technology world, really, like not just computers, but networks, software, everything. In order to build security into it, you oftentimes have to sacrifice a little bit of performance. Sometimes it's more performance or less performance, depending on just what the situation is, what type of threat you need to protect from, what the medium is that you're protecting. And there's efficient ways of doing this, and there's inefficient ways of doing this. And I'm not really looking to have the most secure system in the entire world. I'm looking to have something that primarily has high performance. So I'm not going to be building security into the system that's going to sacrifice that performance, right? Like you could have a car that is very safe by just limiting its max speed to 20 miles an hour. But I don't want to do that. I want to have something that's more like a Lamborghini, so maybe I'll throw in some airbags, and it's going to be mostly up to the driver to protect themselves and drive it safely. So to start doing the kernel configuration, you want to cd into user src Linux, and then we're going to make menu config. All right, and then you'll get this ncurses menu that looks like this. First thing we're going to do is go into our general setup, and our kernel compression mode, we're going to change that from gzip to LZ4. So LZ4 is the fastest option to decompress, but it also does less compression than these other options here. If you want to have a really balanced option, like if you actually want to compress your kernel a bit more and not sacrifice performance too much, you can use XZ. So that's going to be slightly slower than LZ4, but it creates a much smaller image. Kernel compression really isn't going to be that important in what I'm doing. It tends to be more important in embedded systems, so I'm not going to be too worried about it. That's why I'm using LZ4. Let's see, POSIX message queues. So I'm going to disable that. You could disable that if you're not going to be running programs written for Solaris that need to use POSIX message queues. Man, that's a hard word to say. Enable process VM. You can disable that because I'm not going to be using any processes that require those system calls. You might have to research this to see if you are going to be using any programs that require it, but if you're trying to achieve a fairly minimalist approach, you should be fine with disabling this. Same thing with the uselib system call. You can disable that if you're not going to be running programs that are built with C libraries like libc5 and earlier. I'm using glibc. Most of you are probably using that as well, so if you are, you don't need that. Auditing support, we're not going to build that. So this builds in dependencies for an auditing system like SE Linux. So if you're not going to be using that, then you don't need this either. And let's go into the timer subsystem. And then timer tick handling. So we're going to change this to a periodic timer. This keeps the CPU clock running at a constant rate, so it's not going to enter a sleep mode. And as a result, your CPU will use more power over time, but it's also going to have better performance. And because we're using that, we also don't need the old idle dietix config, and I also do not need high resolution timer support. So now into CPU task time and stats accounting. And here we can disable a few things to lower the system overhead. So I'm going to disable the BSD process accounting, as well as the export task process statistics. And these could create some harmless errors in HTOP or other process monitors, but like I said, it's harmless. Let's see, the kernel log buffer size. So you can change this buffer size if you want. The size of it is in KB, and this number here is it represents a power of 2. So how much space you want to use. It's currently 2 to the 18th, or 256 KB. So I'm going to set it to 32 KB, which would be 15, or 2 to the power of 15 rather. Same thing with the CPU kernel log buffer size. I'll just set that to 15. And the temporary per CPU print K log buffer, that can be as low as 12. All right, let me see, what's next? All right, so the initial RAM file systems and RAM disk, I'm going to disable that because I'm going to be building the drivers for my hardware directly into my kernel. So there's actually no need for an init RAM FS if you're going to do that. So you don't actually need to build that into your kernel either. Compiler optimization level. So this was already set in my kernel that I downloaded for performance. I suggest you set it as that as well. Optimize for size. This is, again, really only something that I see people use in embedded systems where there's very limited space and your system really is just doing a dedicated task or 1 or 2 dedicated tasks, like if it's a vending machine. So yeah, you want this to be optimized for performance. All right, and for our slab allocator, this should be set to slub, and that's already set as that. All right, and that's it for the general setup. So now for the processor type and features. Let me scroll to this part in my notes. So as the name implies, this is the part where we're going to optimize our kernel for the CPU that we're using. So I'm going to disable the MPS table. We don't need that in a 64-bit system. We'll also disable support for extended non-PC x86 platforms because I'm not even going to be using standard x86 platforms. Now down in the processor family, I'm going to change this from generic x86, x64 to Core 2 newer Xeon. Now this actually refers to any Intel CPU that's newer than a Core 2. So that includes i3, i5, i7, i9, and of course Xeon. It doesn't include Atom CPUs because, as you can see, there's a different one for that right down here. But if you're using any of the aforementioned Intel CPUs that are in i7, i9, etc., then you want to use this as your processor family as well. If you're AMD, then you're going to want to use this one up here, I'm pretty sure. For maximum number of CPUs, change this integer to the same number of threads that your CPU has. So I definitely don't need 64 because I don't have a Threadripper. I have a 4790K, so I'm going to need to change it to 8. Now this is purely to save some memory because each supported CPU adds about 8 KB to the kernel image. So you want to set this to as low a number as possible, which is just how many threads you have. Keep in mind though that you'll want to change this whenever you upgrade your CPU because you won't be able to access more threads than whatever you put in here. Multi-core scheduler support. So this is a bit of a mixed bag. It increases your overhead slightly, and it doesn't seem to be very useful on my CPU. This might be because I only have 8 threads though. So if you're on a Threadripper or some other CPU with many threads, then you should experiment with the setting, decide whether or not it's best for you. Some people with better CPUs say it is. For me, it's best to turn it off though. Reroute for broken boot IQRs can be disabled. This only seems to be useful on older chipsets. And by the way, when I'm talking about older chipsets and things like that, I'm referring to hardware that is more than 10 years old, like basically CPUs before Sandy Bridge. So if you're on any Core i CPU, even if it's a Haswell like mine or a Sandy Bridge, it still counts as new for the definition of new that I'm using here. Intel MCE features I'm going to leave on since I'm on an Intel CPU, but AMD MCE features will get turned off since I'm not using AMD. Same thing under performance monitoring. So make sure that you only have the Intel options checked off if you're on Intel and AMD if you're on AMD. I'm going to disable the IOPERM and IOPL emulation. This is more necessary for legacy applications, which, again, I'm not really using any on this system. CPU microcode loading is something that we want to have, so that allows us to update the microcode for our CPU, and of course, disable microcode loading for any CPUs that you aren't using, AMD in my case. Level 5 paging support, we definitely don't need, and you won't need this for a very long time, at least as far as my understanding of it goes. So level 5 paging tables essentially allow your CPU to use very large amounts of RAM, like we're talking petabytes of RAM. And I haven't even heard of any supercomputers or even supercomputer clusters that are using that much RAM. I've seen a couple that address a few terabytes, but never a petabyte or more. So we'll leave this option for CPUs far in the future. I'm not going to need it in my system. Numa memory allocation and scheduler support. So this is another area where results may vary. If you're using a single CPU, like single physical CPU, and it's like mine with only 8, 12, or possibly 16 threads, then you won't need this because all of your cores will share the same memory bus. But if you're on a chip with multiple Numa domains, which would be something like a scalable Xeon where you can have multiple CPUs on a single board, or a Threadripper, which has just a ridiculous amount of cores and threads in one chip, but still uses multiple Numa domains, then you'll want to enable this. All right, and check for low memory corruption. This honestly isn't that useful. What it pretty much is supposed to do is it detects corrupted memory in your BIOS and tries to prevent it from affecting the rest of your system, but a corrupted BIOS is extremely rare these days, especially if it's the manufacturer's default BIOS. If you're going to be flashing your BIOS, then you might want to leave this on because it could be a bit buggier, but even then, it seems very rare that people with custom BIOSes are running into low memory corruption. Next, we'll want to enable MTRR cleanup support, and we'll set both of the values to 1. This one already had the default values. For the memory protection keys, this is another area where you'll have to make a decision. So memory protection does make the system more secure, but it also impacts performance. I'm going to disable it, but if you're unsure, I encourage you to read up on this feature so you can make a more informed decision for yourself. EFI runtime service support. If you're using a UEFI configuration, then you'll want to keep this enabled. If you're using an MBR configuration with an MS-DOS MS-DOS partition, then you don't need to use this. The key exec or KEXEC, I'm not sure how you're supposed to say it, but this system call can be disabled as long as you're not going to be loading different kernels. If you don't want to switch your kernels frequently, or if you do want to switch your kernels frequently, then I suggest that you leave this on. We can also disable the kernel crash dumps because this goes with the KeyX module. And building a relocatable kernel. So this is actually pretty useful if you're going to be poking at your kernel a lot and changing things, because it makes it easier to boot a recovery kernel in case you mess up, but it does require the KeyX system call to work. So I'm not actually going to be building this into mine since I didn't build that. But if you're experimenting with your kernel a lot, then you should leave this on, as well as the keysec system call, so that you can boot to a recovery kernel. All right, and that's it for that section. Now for the power management. All right, so suspend to RAM and standby. If suspending your system is something that you actually want to do, then you'll need to enable that. Some people call this sleep mode, so same thing. If you want that, go ahead and build it in. Personally, I only find sleep mode to be useful on laptops, and I'm building this kernel for my desktop, so suspend is really of no use to me. Same thing with hibernation. It's of no use. I just leave my desktop on 24/7. See, I'll also disable the power management debug support. And make sure to build in the CPU idle driver for Intel processors if you're on Intel. All right, bus options. There's actually nothing to really change in here if you're using a newer kernel. Folks with the older kernels, though, you'll have to look up how to configure this because you won't have as simplified of a view in here if you're on like kernel version 4 point something. There's several things that you can tweak in here. Firmware drivers should look like this. Not really much to change. Again, if you're using a newer kernel, folks with older kernels, you'll have to look up how to configure it. Under virtualization, we want to enable the host kernel accelerator and do it as a star. So when you do it as an M, that means that it's a module. But again, we don't really want to be using modules since we're not going to be building an initram FS. So we'll do the star to just build it directly into our kernel. But what this does is it allows for guest VMs to have better network performance. So if you're not going to be using VirtualBox or running any type of virtual machines, then this feature probably isn't going to be necessary for you. Under Enable Loadable Module Support, we just want to disable Forced Module Unloading. And under Enable the Block Layer, we just want to turn off block layer debugging information. Then under Networking Support, I'm not actually going to be making too many changes in here. Just disabled AM radio because I'm not going to be using it. So my configuration here is already pretty minimal, but basically you can disable any form of networking that you're not going to be using. So if you don't want Bluetooth, then don't build it in. If you don't want wireless, go through and disable all the wireless options, so on and so forth. Device drivers, this is going to have a few changes to make. So PC card support, we can disable that because I don't have that on my hardware. Under block devices, we want to change the number of loop devices to pre-create at init time to 0, because it's just better to create those loopback devices on demand instead of just having 8 of them floating around when you don't actually need them. If you're on an NVMe drive, be sure to build support for it into your kernel. I'm not using one, so I'm not going to do that. Under Scuzzy device support, we want to enable, let's see, I don't see it. Here it is, asynchronous Scuzzy scanning. So we want to enable that because it could actually speed up our boot time. So it's a nice feature to have. Next, I'm going to disable multiple devices driver support because I'm not using RAID or LVM. If you're going to be using either of those, then you'll want to keep this enabled. And I'll also disable Macintosh device drivers since I won't be using any Mac hardware. And in network device support, I'm not going to change anything, but you could do something like disable wireless if you don't want to be using Wi-Fi in here. In input device support, I'm going to be disabling PS2 keyboards and mice. Actually, I don't think the keyboard has PS2 option in it. No, the mice does, though. Same thing, you can do the same thing with joysticks and gamepads if you're not going to be using that. I actually have a Xbox controller that I connect to play certain games in Steam, so I'll keep that one on, but I'll disable tablets and touch screens because I'm not using either of those. All right, and under graphics support, we have a few things that we need to change. So our maximum number of GPUs, I'm going to change this to 2. I don't know anybody who has 16 GPUs in their system. I just have the 2 integrated and dedicated graphics, each supported by 1 card or CPU. So change that to whatever you're using unless you already have 16 GPUs, in which case you're a really cool guy, right? All those GPUs running at once. And then build in your graphics card driver. So I think it's down here. Yeah, there's the AMD GPU, and then the NoView for NVIDIA, and then Intel HD graphics. And I also have this one enabled, VirtualBox graphics card, because I want to be able to use this same kernel as the host operating system as well as a guest operating system. So to use this as a VirtualBox guest, you'll want to have the VirtualBox graphics card. And I think that's it for device drivers. So now on to file systems. Make sure that your file system is built in here. So I'm using a ext4, and I already have the options that I need built for that. I'm also going to disable miscellaneous file systems. It's in here somewhere. Here we go. No need for me to have that. You could also disable network file systems if you're not going to be using any type of network file system like a NAS drive. I do have a NAS drive that I like to use, so I'm going to keep that enabled. Now for the kernel hacking, there isn't too much to do in here. What I will do is under the RCU debugging, I'm going to change this stall timeout to 3 seconds. And then finally, for the Gentoo Linux options, under your support for init systems and service managers, build in support only for whichever init system you're using. So if you're using systemd, then build in systemd. I'm not, I'm using OpenRC. Also, if you're on Runit, you want to just use this one, the OpenRC Runit, and other script-based systems and managers. So now that we've configured our kernel, let's go ahead and save it. All right, so now it's written, we can exit. Now let's go ahead and compile it. So our command is going to be make modules install and make install. And then this is going to do its thing. Now our kernel is done compiling and you are ready to reboot into it. I hope you guys found this video useful. Thanks for sticking around to the end, and let me know in the comments down below if you have any suggestions on how to improve this kernel configuration. I'll be taking a look at the comments for some tips on a future config, so definitely let me know if you're more of an expert than me, and then you will see your recommendations built into the next kernel.